This video is the third video in a series of 4 where we create a mean application. So far we've created an Angular single page application and slightly enhanced it with a Node.js backend service. Now we're going to improve our backend service by introducing Express.js to make use of the out-of-the-box REST API services that are available to us from Express.js. In this video, we're going to enhance our backend Node server with a middleware component built with Express.js. So Express.js makes it easier for us to register REST endpoints that our single page application can call to receive data responses. So from a high level, we're going to create an instance of an Express application with all the middleware components we require. We will later see what this looks like. Then we will export the Express app and import it into our Node server to then use. So let's begin by installing Express.js, and we're going to do that by running npm install --save express. And then when that's finished downloading, in the backend folder, I'll create a new file called rest.js. Feel free to call this whatever you would like. And within that file, I'm going to import Express.js into a constant with the require express word. We can then create an Express application by creating a new constant called app, for example, and that is going to be equal to express and then open and close brackets. So the purpose of our Express app for now will be to handle the data from our single page application. The end goal for this video is to migrate our diary data service component where we're fetching all of our diary entries into the Express app for now. So our single page application can handle data through the REST service we create in Express and no longer within the single page application itself. This might seem like we're just passing the same behavior from one place to another, but the benefit we will later realize will be when we connect our Node server to a database and we no longer require the data to be stored and handled within the Node server. So we're kind of passing that data responsibility away from the single page application into Node, and then in 2 videos time we'll be migrating it all into MongoDB. So back in the REST.js file that will use Express.js, we're able to register different endpoints for our Node server to respond to. We do this by using the keyword of use, and that will take 3 arguments. It will first take the request and response object, which is just similar to the Node server, but then it will also take a 3rd argument, which is a next argument. So the middleware will register multiple use cases that define different paths, and these are different URIs that we can send our requests to receive different responses. And if a request satisfies multiple paths, we can use the next method to pass on the request to the next satisfying middleware use, and we're going to see how this might work. To return a response from the middleware, we can call the send method on the response object. So let's pass in a string of hello from Express just to demonstrate this. And to make this Express app available to our Node server, we will export the app by using module.exports equals app. And then if we go into the Node server, we can import the Express app by using constant of Express, and then that will equal require, and then we're just going to pass in the path of our relative Express app, which is on the rest.js file. So our Express app provides all the middleware required to replace our existing request listener. So we simply pass that into the server brackets. Now if we restart our Node backend and head to localhost 3000, we can see hello from Express printed into the web page. So to demonstrate how the next keyword works, I'll define a new use case in the Express app, and all we're going to do is console log hello, and then we're going to call next. So when we send a request to our middleware Express app, we can expect hello to be printed into the console, and then the response, hello from Express, will still be returned on the web page. And that's exactly what we can see. Now if I remove the next method call and restart the app, we can see our browser page is loading infinitely, and that's because it's entering this first middleware method. No response has been returned, and it's kind of stuck there because it doesn't know where to go from here. There's no next method that is being called, and that's what's causing our backend server to remain in limbo. We can begin to define unique resource identifiers that enable our backend service to respond to unique requests, and that is beyond this empty localhost 3000 path that we're currently using. To specify the path that we would like to register, we pass in a new argument in front of the 3-part argument of our use method. So within quotes, I will pass in the path as /diary-entries, and this is going to tell Express to only respond to the request if that is the exact path that it is sent for. So let's look at how we can take the method that returns all the diary posts from our diary data service and move them into the Express backend service. I'll first copy the array of data from the diary data service into the Express file under a new array called entries. To help us replicate the eventual database our Express app will connect to, I will just add an identifier field to each entry. I will add keys of ID, date, and entry to them, and change the date to use March, just so we can distinguish between the diary data service values, which all use January, and the backend server, which uses March. And lastly, I will update the diary model in the Angular application, and this will now use ID as a number. And I'm just going to correct the diary data service and the diary form component by simply passing in fake ID values, just so that it compiles. So IDs are used in databases to uniquely identify each row, but in our app we're currently using the index of each item in the array to get that row. We will later see in later videos how this can be beneficial. So in the method body of our ES6 function, I will return a JSON response. To do this, I will use the inbuilt response.json method. The method accepts a comma-separated list of JSON objects within the curly braces. So I will pass in the key of diary entries in camel case and the value of entries from our file. So now within our JSON response, we'll have a key of diary entries, and the value for that key will be all of our entries. So if we restart our node server, we can head to localhost 3000, go to /diary-entries, and we can see that JSON data for our entries being returned to us as text. In our Angular single page application, we will want to update the current getEntries method from our diary data service to now send a HTTP request to our backend service, and Angular makes this really easy for us to do with its out-of-the-box methods from its HTTP library. So to get access to that HTTP library, I will first import the HTTP client module into the app module file, and that comes from the common /HTTP package from Angular. Next, I will inject the HTTP client into the constructor of the diary data service, and that will make it available for all of the methods within that service, which includes the getEntries method. And I will change the diary entries array that is instantiated in the diary data service to be an empty array. Then I will update the getEntries method that we have to make a HTTP GET request to the backend server. And just before I do that, let's take a look at what GET is. And GET is one of the HTTP methods we have previously mentioned and is used for returning data from a RESTful service. We also mentioned the put, post, and delete methods, all of which have respective responsibilities. So to do that, I will call this .http.get, and I'm going to pass in the URI that we have from our browser. This request returns a subscription that we can then subscribe to, where the response from our request will contain that JSON data we saw from our Node backend server. And then within brackets, I will call this .json data, and we can reassign the array of diary entries we have within our diary data service as equal to the JSON data .diary entries. So that .diary entries is going to point to the values of that key within our JSON response. We currently have a compile error on the JSON data.diary entries key, and this is because our Angular application doesn't actually know what that JSON data will contain. It doesn't know what keys we're expecting, it doesn't know what type of values that we're expecting. But we can tell Angular exactly what it contains using angled brackets just after the get method. I'll then open a curly brace to describe the data that is returned. So we will have a key of diary entries, and that will contain an array of diary entry objects. If we had other keys, such as a message, we could just append that using a comma, and then we could have something like message, and then that is of type string. So now our JSON data is able to access the diary entries key, and Angular knows it will return an array of diary entry objects. Lastly, I will broadcast the updated diary entries using the diary subject, passing in the diary entries. In the diary component file, we also have a compile error as the get diary entries is no longer returning an array. I will simply remove the assignment to remove that compile error. Okay, so back in our application, we can see there are no entries being returned. In the console, we can see that this is due to a CORS policy. So let's quickly discuss CORS. So CORS stands for Cross-Origin Resource Sharing. It is a policy we apply to our servers to specify who and what kind of requests can be sent to it. It's kind of a security mechanism to control the incoming traffic for the server. So as our single page application makes requests to our backend server, we will need to enable CORS on the backend server to allow those requests to then be handled. So in the REST.js file, we will need to enrich the responses that we have with specific CORS headers that enable our Angular frontend to communicate with the backend. So before we start looking at how we're going to do that, maybe stop to have a think about how we can achieve this on your own. So earlier we mentioned that the Express app can run code before all of the requests, and that's because of this next method that is provided. So to do this, I'll create a new use for our middleware, and I'm not going to specify a path, so that means all the incoming requests to our Node backend are going to be calling this middleware method. Within that method, I will set the header for 3 CORS policies, and these are access control allow origin, access control allow headers, and access control allow methods. Allow origin will tell the browser which domains the backend request is accessible to. We will pass the value of an asterisk in after a comma to specify all domains can send requests to be handled. When a request is sent from a domain, it will typically include headers to specify details of the request, and we will want to expand the default headers that are accepted on the backend service to include origin, x requested with, content type, and accept. It's a good idea to check out documentation on CORS headers at developer.mozilla.org, for example, and these will provide details on what the headers mean and how they can be used. Lastly, the allow methods policy will specify what type of HTTP methods we will support, and for our application we will support get for getting all the data, post for adding data, put for updating data, and delete for removing data. I will also add in options, which is a request for information about the communication options available on the request or response identified by the request URI. This is particularly useful when requesting information about what allowed methods from the client when requesting a response from the backend server. And then lastly, below this, I'm going to call next to ensure all incoming requests to our Node backend server are handled appropriately within the server. I'll restart the server and navigate back to the application. So let's take a look at the application, and we can now see all the diary entries are returned. However, this request has come from a HTTP method call to the backend Express server and not from the static web page, and we can see all the dates as March. This has been a really big step towards creating our backend server where we can now register URIs in the Express server, enriched with CORS access, and where two servers are able to communicate the shared data between them. In the next video, we're going to continue to enhance the Express endpoints to allow us to add, update, and delete methods with HTTP requests.